Hey, are we just waiting on more people?
Yeah, for right now.
So what are you using on your computer for the math or whatever?
I can show you. It's this. It's just the regular calculator.
Okay. So I have like a TI-84. Could I use that?
Yeah, that works.
Hey, so do you have your lab pulled up?
I am about to. Give me a second.
Mhm.
Okay, now I do.
Okay, on page 4, where it has like equation 1 and 2, are we using equation 1 for table 6.2?
Yeah.
Okay.
The yeah. So it's pretty much the same thing. This one and then the other. So this equation is pretty much the same thing as the uranium equation. It just has like one thing changed, but this is the general. You should be able to use that for everything.
Okay. Is that like Y thing on the calculator? That upside down Y?
It should be. If it's not, then we can just take this number because that is 1 over, it's the decay constant.
Oh, okay. So that Y is 8033?
No, so this is actually this number.
Oh, okay. I see what you're talking about.
So what formula are we using for table 6.4? Is it the same formula? Because I think I did that one and I didn't get the right answer. It didn't look right.
Let's see. No, so instead of the equation 1, we're actually going to use a different equation that is specific for uranium. It's a little bit different.
Should we try to do the first one on 6.2? Or do you want to wait for some more people?
Well, let me do this.
So if I'm putting it in my calculator, would I do 1 divided by 0.1244 to the 10th power times -3?
So you'll do, rather than trying to do all of that math, we can just do it once, and then that'll be the same. It'll be the same number for everything. So for the decay constant, it's 0.0001244, and then you take 1 over that number. So 1 divided by, and it's should be the same. 0.01244. Yeah. So
That whole number?
yeah, let me try it a different way. Nope. Try 10 to the third. That's -3. Okay. Never mind. We're just going to do 8033 because that makes it easier.
Okay. So no decimal, just 8033.
Yeah.
Yeah.
So for 6.2, it's asking us to do a bunch of equations. So it wants us to do 8033 times natural log, oh my lord, natural log of origin divided by sample, so 6.25 divided by 1, and then we take the natural log of that and multiply it by 8033.
So 6.25 divided by 1 times 8033.
Yeah. Well, so the 6.25 divided by 1 you take the natural log, which is this ln button, and then it will spit out a number like that, and then you do that times 8033.
So
And
if
it
I'm
gives you this.
putting it in my calculator, I would do 6.25 divided by 1, and with that answer, hit the ln button, or ln before the equation.
Let me see if I can find my calculator.
Oh, I got what you got. I got that 1.8325 when I did ln. I just did ln 6.25, and I got 1.8325. Yeah, I think I got the same thing as you. 14,721.
Okay.
So with that number 14,721, would that go in the age year BP or?
It should, yeah. Let me just real quick come over here.
Okay, so I have a question.
Yeah.
Okay, so to find the age year, you said that we do the 8,033 times the LN, and then you multiply that, and you do the 6.25 divided by the 1, right? Which is the sample.
Yes. So the A, if you're looking at table 6.2,
Mm-hmm.
go down to here. The A origin
Mm-hmm.
is what we're going to put for the A standard
Okay.
in the equation. And
Mm-hmm.
then this is the A sample.
Okay.
So you plug that in. And so you do A origin divided by A sample.
Uh-huh.
And then when you do that, if you're using the same calculator that I am, you'll
Okay.
take whatever that is, and then you'll
Uh-huh.
do the natural log of that.
Okay, so after we find that answer, we have to do the natural. No, can I ask you why do we have to do that?
So if you do it any other way, it's going to turn
Uh-huh.
out wonky.
Okay. So with that, okay. So I got after I did the LN, after I found the answer to the equation, then I did the natural log of that, I got 9.597. I'm using a TI-84 calculator though, so maybe that's why.
Okay, so if you're doing it on the TI-84, you have to do ln, and
Mm-hmm.
then it should give you like an open parentheses, and then you do
Yeah.
6.25 divided by 1, and then close parentheses, and then press enter. And it'll spit out the right number. And then you just take that and multiply it by 8033.
Okay. Okay. And you
And
said it would be the age year, right? So how do we find um the lowest unit? I don't know how to pronounce it.
LOS unit,
Yeah.
I'm not entirely sure. Let me check my notes.
For your age year, did y'all just put 14721.12?
Yeah, that's what I did.
Okay.
She didn't say anything about how she wanted, so
Yeah. I don't want to do that. We'll just do this. What was it? 14?
Easton, you
14721.12.
Easton, you might be able to put your like Memphis email in, and it'll let you edit it.
Yeah, it's going to take some time. I just don't want to do it right now. Okay, so for the second one, we would do 6.25. This might be easier. Yeah.
Divided by 0.5 or 1?
Okay, so you do 6.25 divided by 0.5, and then take the ln of that.
Okay. I got 12.5 for that. And for Ellen, I got 2.5.
Eston, is that app on your computer or something? Because I have the same thing where I have to, in order to edit, I would have to like draw the numbers in.
Mm-hmm.
So is that app on your computer? Like I tried to save it to my laptop and then like edit as a PDF on Microsoft Word or something, but it's not letting me do that.
So I'm using Adobe Acrobat Reader DC, and
Okay.
I'm using the free version because I haven't set up the paid version. I
Okay.
like to print mine out and then scan them, but
Oh, okay.
it should be roughly the same thing if you aren't using the free trial and it has you log in and everything. That's too much for right now.
Yeah.
So, did you get 20289?
I haven't started mine yet. I was still trying to figure out how to put these numbers in the table. I'll do it right quick though.
So what did you get?
I got 20289.1782.
I got 20,963.
Ooh.
25.
I wonder if I can show you my account. Can you see my calculator?
Yeah.
Can you see like if I did?
Hang on, Hannah. Can you talk so your thing will pop up?
Yeah.
Because I think. I don't know.
Do you think I entered something wrong?
What'd you say you get?
So you had ln of 12.5.
Uh-huh.
Okay, hold on. Let me just make sure that I'm doing it right.
You still need to see mine.
No, you're good.
Our numbers kind of sounded the same, except after the 20,000.
Yeah, I typed in the wrong number. So 20,289.
Okay, cool. And you're just not doing the decimal?
Yeah, if she wanted us to do the decimal, then I would do the decimal, but it just makes it a little bit easier to not do that, I find.
Yeah, it does.
I mean, I don't think like 0.21 of a year is really going to matter when we're talking about like 14,000 years. So,
Y'all said 20,289, right?
yep.
Okay.
So the next one I got 25,857.
25,857.
Yeah, I got that.
Yep.
Yeah.
This is actually pretty easy now that I know.
It gets
Yeah, I think
easier. It definitely gets easier as you go on.
yeah, that formula helps a lot. As long as you have that formula written down and just remember it, then you'll be okay.
So then what'd you guys get for the next one?
I'm still doing mine.
I got 31,425.
Yep.
Mhm. All right, I got the next one.
What'd you get?
I got 38,785.
Sounds right to me.
All right, I got the next one.
Go for it.
70,211.
Yep.
The next one is 75,779. Well, yeah, 779.
75,000.
Yeah, 75,779.
Okay.
All right. Now I gotta figure out this lowest unit.
Okay. Oh, so if you go down this little this thing that's just peeking up on the bottom of my screen,
Yeah.
that is what we're going to use for the lowest system. So that's technically, there's a hiatus and then Peoria, Roxana, Loveland, and Mariana. And so if it's Agents 7,000, so this first one we would put as Peoria.
Yeah. And then the next one would be hiatus.
I
Or
think we would just say that it's still Peoria.
yeah. Hiatus.
This one I would say would be the hiatus, yeah. Or we could put Peoria / Roxana. And then 31 would definitely be Roxana.
And so would number 5, yeah.
So that should be it for this one. So are there any questions on how we found any of this?
Nope.
We're all good?
Yeah, no, once I got the equation, it was fine.
Yeah, I wish she would have explained it like we did.
Yeah, she explained it a lot harder than it needed to be.
Yeah, I've been teaching people for a long while, so, and I understand it very clearly. Okay, so for the next one, we are going to page 4, and we're going to use that bottom equation. We're going to use this equation. It's not a whole lot different. The only thing you're doing is 1 plus daughter divided by parent. And I can help explain that a little bit. So we're going to need this as well. It's a little confusing, but really we only need the decay constant. So decay constant and half-life. So it's the same thing. We're just doing 1 over this number. So if someone wants to do that real quick, I can write it on here.
I'm trying to do it right now.
Is that 1 divided by the 1.55?
Mm-hmm.
My calculator is like not
So,
understanding.
so if you're doing it, you can actually do 1.55, and if you're on the TI-84, there should be a little e to the x power, and you can do 1.55, press that e button, and then do -10. And it will give you the same answer.
And divide that answer by 1, or
So you'll do 1 divided by that answer.
um, I got 80.041.82473.
I got 64 point something.
And I got 2.92, a long number.
Okay, give me a second. Holy crap. Okay, so if we doing this correctly. Okay, hold on. Okay, we have to fill in this section. So instead of using this number, we would do this number.
Oh,
So it should be 9.84 times 10 to the negative 10th. And then 1 divided by that. And it's a stupid long number.
is that the number you got?
Yeah,
Yeah.
so 1,016,260,162.
And we're going to be using that in the equation.
So we'll just take that, and instead of doing the 1 over the upside down y, which is technically gamma, we'll just take this number and plug it in for that 1 over. So then we have to take parent. So we take 10 divided by 90, which is 0.1, 0.11111111, and then do plus 1,
Okay.
and then take the natural log of that. So for the first one, for this one,
Uh-huh.
it should be, for the natural log, 0.105.
Yeah, that's what I got.
Okay, and then you multiply it by this big number.
Okay. I got 107.073694.6.
Yeah.
Are you going to put that whole number minus the decimal?
Yeah, just for right now. If you wanted to do it a different way, you could say that it's 1 to the 1 times 10 to the 8th.
Eston, if you don't mind, could you like write it out like the step by step?
Sure.
Because I'm totally confused. I don't even know how y'all got all of this.
Okay, so you take this, so there's really 3 things that we need.
Uh-huh.
We need this decay constant,
Mm-hmm.
and then we take that and divide it by 1, which is this big number, or 1 divided by that number.
Okay.
And then we take the daughter atoms, so
Uh-huh.
10 for this first one,
Uh-huh.
and divide that by 90,
Uh-huh.
because the equation is d over p.
Okay.
And then you take that number, and which is 0.11, say, you add 1 to it, so it's now 1.11,
Mm-hmm.
and then you take the natural log of that.
Okay. So are we going to use that big number through all of the other
Yes.
Okay.
I just did number 2.
What'd you get?
For the final answer, I got 226,771,901.
Okay. And that looks roughly That looks like it should be roughly correct.
She said on the Zoom that she's not expecting us to like have the exact answer. She said she's gonna let us round it.
Yeah, so if you wanted to do, rather than having this big long number, for this one at first, you could do 1 times 10 to the, where's that? 10 to the 8th. And that is the scientific notation version of this big long number. And you're just rounding close enough that it's should be fine. So for the second one, we would do 20 divided by 80 plus 1, take the natural log, and then multiply it by this.
I got the third one.
What'd you get?
I got 362474 536.
Yep.
The numbers are like huge to put in.
Yeah, that's the only bad thing about it. It's not what I wanted to do. And that's really the only thing that people will have problems with.
So after we do 40 divided by 6, we find the natural log of that, and then you multiply by that big number?
Yeah, by this big
Okay.
number here.
Okay.
I got the next one, but I can wait if y'all want to do it.
Yeah,
Yeah.
please, because I'm trying to see if I'm doing it right or not.
Yeah, I was like, okay, I don't want to give her all, let her do it so she knows how.
So I got, do it start with a 6?
Mine started with a 5.
And mine started with a 4, so
Oh, shoot.
let me make sure I did it right.
40 divided by 60 times that big number. That's all we got to do.
No, you do 40 divided by 60 and then add 1 to that.
Oh, yeah, okay. I forgot about that part.
Do the ln of that number. And then times it by that big ass number.
Okay.
Okay, yeah, mine does start with a 5 now. I forgot to add 1.
Sorry, y'all.
You're fine.
And then times 1016260. So I got 519131731.
Yep.
Okay, cool.
Yep.
And I got the next one, but I can wait.
So you got 515. Just
I
read
got
me the number again.
519 131 731.
Okay.
You can go ahead and read the next one. I know how to do it now.
Okay. I got 70441786.
Yeah.
And I got the next one if you want me to say it.
Give me just a second.
Okay.
Do it start with a 9?
Yeah, mine does.
Okay.
Okay, what'd you get?
I got 9311897767.
Yeah, that's what I got as well.
Okay, cool.
I just worked out the next one.
+1.
What'd you get?
I got 101 626 0163.
And you did 70 divided by 30
Yeah.
plus 1,
Yeah.
the natural log, times this big number. Because I got something different.
I added it. I didn't do times. That's why I was like, this is the same.
What'd you get, Eston? Did you get 1, 2, 2, 3, 5, 4, 9? Wait, 1, 2, 2, 3, 5, 4, 9, 5, 9, 7. Okay.
Yeah.
My bad, y'all. I added that number.
That's okay. I've got the next one, so whenever y'all get an answer, shout it out.
I got 1635607 634.
I got 633, but it's close enough.
Okay.
I got that last one, whatever.
You got 3-4 instead of 3-3.
No, I was just saying I got the last one.
Okay.
Whenever y'all want me to say it.
Go for it.
All right, I got 23400 25500.
I got 499, but it's close enough. I don't
Okay.
think she's gonna count off for it. So now we have all of these done. What's the next?
I think next is this little chart. She did the first dot. It was on the 6 and the 60. I feel like I'll be able to do the dots, but those questions might be a little under it. Wait, so where do we find the dots again? I remember her saying.
So it's the number of daughter atoms. You're basically gonna take the same one. So it's from table 6.4, and it's the U to uranium to lead. So at 68,000 years, or 680 million years, there are 10 daughter atoms. And this changes to billions of years. So 0.6 is roughly here, and there's 10. So you're just going to reference back to the thing up here. And so at 1.4, there's 20. So 1.4, and there's 20.
Yeah.
And so you'll just keep doing
Okay.
that up to a certain point.
Okay, that's cool.
So for 60, so you'll have 3 different dots here. And then you'll just draw a line through them. Should look pretty much like that. Just if you're not doing it on a computer, it'll look better.
Okay.
But do
Should
we
we like
understand?
highlight if we're doing on paper like our line? Do you think
You
we should, or do you think it matters?
You certainly can. I mean, if you're doing it on paper, then if you just make your dots pretty big and then draw a line through all of them, I don't think it'll really hurt anything.
So is that the only line we're making?
Yeah, so it just says you plot the different dots and then you draw a line through the data when it's finished. And so for the first question, for the relationship between half-life and the slope of the decay line, well, we've actually built up the number of daughter atoms. So to get the decay of the parent line, you basically just flip this one over. So you'll have your graph and it'll look something like this.
Okay.
And this is X and this is Y. And it basically is just asking what the relationship between parent decay and this line is.
Aren't they just like flipped?
Well, so the relationship between half-life and the decay line is half-life is the time it takes for one parent atom to decay halfway. And so the slope of the decay line is, oh God, how would you say this? The slope is higher the more parent atoms there are, but the slope decreases the longer time goes on. Does that make sense?
Kind of.
So it's higher the more parent atoms there are, but it decreases the more time goes on.
Yeah. So if I was going to display it as a number, let's just say it's 1 over 2. And the longer time goes on, it goes 2 over 2, and then 3 over 2. And it'll actually go backwards. So that was a bad 3 over 2. It'll go down to 2 over 2, and then 1 over 2, and then 1 over 4. That's not a 4. And then 1 over 8, and so on and so forth. And that's basically just what this is doing, just in reverse.
On number 2, do you think it'd be like 40 billion? I mean, 4 billion?
45. 45% lead?
Yeah, and it says like at the
Yeah.
bottom.
You could say roughly 4 billion.
What does 50-50 parent-daughter mean?
So if you go back to table 6.4, when you go down the daughter atom and the parent atom list, 50-50 is when there is exactly half parent, half daughter. And so for the half-life, that is quite literally what it means for a half-life. So that half-life is the time it takes for the whatever you're using, 50-50 split to happen. So for a chunk of uranium to become 50% lead, it's 4.5 billion years. So it's this big. That is what we're looking at. And this is roughly 4.5 billion years. And because this 7 is above the 5, then it's going to round this 4 to a 5. And then we'll just say it's 4.5 billion years, which is the same as this number. Again, roughly, we're rounding. But it basically just means that for this question, the relationship is the 50-50 split is the half-life.
Okay.
So for this next figure 6.6, rather than using the 206, we're going to use the 207. So the one that we filled in, those are the years that we're going to do.
On 6.2 or 6.4?
6.4.
Okay.
So the one where we had to multiply by like 1 billion or whatever, that big old number,
Yeah.
we're going to use that to inform us about 40, 50, 60, and 70, the years at least.
The number we put in?
Yeah.
Okay. Forty's like 5. Uh-oh.
I don't have the numbers. I've not been keeping track of the numbers and everything, so I'm just drawing a basic line that should inform us roughly where everything is. And then once we plot those points and then draw the line, that is the end of the lab.
Thank you for helping us.
Yeah, no problem.
Right. Thank you.
Have a good day.
You too.